Imagine a world without water. Vast, desolate landscapes where the sun beats down relentlessly, drying out every living thing. For most creatures, such an environment is a death sentence. Life, as we know it, fundamentally depends on hydration. Yet, in the heart of some of Earth's most extreme deserts, a remarkable inhabitant defies this universal truth. It lives, it thrives, it raises its young, all without ever taking a single sip of water. This is the story of the desert kangaroo rat, a true marvel of survival in an unforgiving land. Our subject is the desert kangaroo rat, a small rodent, no bigger than a human hand. These creatures are native to the arid and semi-arid regions of North America, particularly the southwestern United States and Mexico. They are named for their powerful hind legs, which they use to hop like miniature kangaroos, often covering significant distances in their search for food. But their most astounding characteristic is their complete independence from external water sources. How does an animal, living in a place where water is so scarce, manage to sustain itself without ever drinking? To understand this incredible feat, we must first appreciate the severity of their environment. Daytime temperatures can soar, often exceeding 100 degrees Fahrenheit, or over 38 degrees Celsius. Humidity plummets, making any exposed moisture evaporate almost instantly. Standing water is virtually non-existent for much of the year. For most animals, this means constant vigilance for water holes or reliance on water-rich foods. But for the kangaroo rat, these worries are entirely foreign. Their survival strategy is built upon a foundation of water independence, a profound contrast to nearly every other living organism. One of the first lines of defense against water loss is behavioral. The desert kangaroo rat is strictly nocturnal. It spends the intense heat of the day deep within its burrow, emerging only under the cool blanket of night. This simple yet effective strategy allows it to avoid the most brutal evaporative conditions, reducing its need to dissipate heat and, consequently, its water loss. While other desert dwellers brave the sun, the kangaroo rat conserves its precious internal moisture, an elegant solution to an omnipresent threat. Beyond simply being nocturnal, the kangaroo rat constructs an elaborate underground burrow system, a sophisticated feat of natural engineering. These burrows can extend several feet below the surface, insulated by the surrounding earth. The network often includes multiple entrances, escape tunnels, and dedicated chambers for nesting and food storage. This subterranean architecture is not just a refuge from predators, it's a precisely regulated microclimate, crucial for its water-independent lifestyle. The desert itself becomes its insulator, its protector, its hydration chamber. Inside the burrow, the air is significantly cooler and far more humid than the scorching, dry air above ground. During the day, the temperature inside a kangaroo rat's burrow can be as much as 20 to 30 degrees Fahrenheit cooler than the surface. This stable, cooler environment dramatically reduces the rat's need for evaporative cooling processes like sweating or panting, which are major sources of water loss for most mammals. Furthermore, the air inside becomes saturated with the rat's own exhaled breath, trapping moisture and creating a small, self-sustaining humid haven. It's a carefully managed internal atmosphere. So, if it doesn't drink water, where does its essential hydration come from? The primary source is its diet. Desert kangaroo rats are predominantly granivores, meaning their diet consists almost entirely of dry seeds. They gather seeds from various desert plants, carefully husking them before storing them in their cheek pouches or caching them within their burrows. On the surface, this might seem counterintuitive, eating dry food to avoid dehydration. But the secret lies not in the direct water content, which is minimal, but in the chemical composition of these seeds. The true genius of the kangaroo rat's water acquisition lies in a process called metabolic water production. When the dry seeds are consumed, the rat's body chemically breaks down the carbohydrates, fats, and proteins within them. A byproduct of this metabolic process is water. For the kangaroo rat, this internal production of water is so efficient and robust that it fulfills virtually all of its hydration needs. It is, in essence, an internal water factory, creating the vital fluid from the very food it eats, eliminating the need for external consumption. The kangaroo rat's survival is a delicate balance of maximizing water intake and minimizing water loss. While metabolic water provides its essential supply, its body must be exquisitely designed to retain every precious drop. This balance is a masterclass in physiological efficiency. It means every bodily function, every waste product, every interaction with the environment must be optimized to preserve moisture. Without this intricate control, even the most efficient metabolic water production would be insufficient to sustain life in the desert's relentless embrace. Perhaps the most astounding adaptation for water conservation in the kangaroo rat lies in its kidneys. These aren't just efficient, they are extraordinarily so. Compared to other mammals, including humans, the kangaroo rat's kidneys are capable of producing urine that is incredibly concentrated. This means they extract almost all the water from waste products, expelling only a tiny, highly concentrated amount. It's an internal filtration system operating at peak performance, a biological marvel that allows it to excrete waste without squandering valuable water. To put this into perspective, a human can produce urine roughly 4 times more concentrated than blood plasma. A kangaroo rat, however, can achieve concentrations up to 14 times greater than its blood plasma. This is an almost unparalleled capacity in the animal kingdom. Imagine how little water is lost with each excretion. It's a tiny, dense pellet, a testament to the absolute priority of water retention. This extreme physiological design is one of the foundational pillars supporting its water-independent existence. Similarly, the kangaroo rat's digestive system is engineered to extract maximum moisture from its food. Its feces are exceptionally dry, almost pellet-like. This is another critical component of its water conservation strategy. Every avenue for water loss is meticulously managed and minimized. From the moment food enters its body, to the final expulsion of waste, the entire process prioritizes the retention of moisture. It's a continuous, unbroken chain of water-saving mechanisms, each link reinforcing the next, enabling life where water is a luxury. Even respiration, the simple act of breathing, presents a challenge in water-scarce environments. As warm, moist air is exhaled, water vapor can be lost. However, the kangaroo rat possesses specialized nasal passages, incredibly intricate and efficient moisture traps. As air is inhaled, it is warmed and humidified. As exhaled air passes back through these cool nasal passages, water vapor condenses, effectively reclaiming much of the moisture before it leaves the body. It's a precise heat and moisture exchange system, ensuring minimal respiratory water loss. Unlike many mammals, including humans, the desert kangaroo rat does not possess sweat glands across its body. Sweating is an effective way to cool down, but it comes at a significant cost: rapid water loss through evaporation. For an animal that never drinks, this would be catastrophic. By relying on nocturnal activity and its insulated burrow for thermoregulation, the kangaroo rat eliminates the need for this water-costly cooling mechanism. This absence is not a deficiency but a crucial component of its complete hydration independence. Beyond its internal physiology, the kangaroo rat also employs clever behavioral strategies to enhance its water balance. It collects and stores large quantities of seeds within its burrow system. Over time, the seeds absorb some of the humid air present in the burrow. While this absorbed moisture is not substantial enough to be considered a drink, it subtly increases the water content of the seeds, providing a slight, yet measurable, boost to its metabolic water production when consumed. Every little bit counts in this extreme environment, and even stored food participates in the water economy. The desert kangaroo rat is just one example, albeit an exceptional one, of a group of animals known as xeracles, creatures supremely adapted to arid conditions. While others may derive some moisture from succulent plants or dew, the kangaroo rat stands out for its near-total reliance on metabolic water and extreme conservation. Its survival is a testament to the diverse and intricate ways life finds a foothold, even in the most challenging corners of our planet. It underscores that what might seem impossible is, with the right systems, entirely achievable. The desert kangaroo rat's ability to live without ever drinking water is not a singular trick, but a symphony of interconnected systems. From its nocturnal schedule and expertly crafted burrow to its dry diet, metabolic water production, and incredibly efficient kidneys and nasal passages, every aspect of its being is seamlessly integrated to solve the fundamental challenge of desert life. It is a living, breathing blueprint of water conservation, a biological masterpiece perfected to thrive where others cannot even survive. It truly pushes the boundaries of what we understand about life's resilience. In the vast, silent stretches of the desert, where every drop of moisture is precious, the desert kangaroo rat offers a profound lesson. Its existence is a powerful reminder that life's potential for ingenuity and survival is far greater than we often imagine. This small creature, through an array of sophisticated mechanisms, conquers one of nature's most formidable challenges. It navigates its arid world not by finding water, but by creating and conserving it from within, an enduring symbol of life's remarkable capacity to persist, even where the impossible seems to be the only reality.